Okay, so one of the things I need you to learn for today is what I is. So this one is square root of 81 is 9, and then I makes it an imaginary number. Let me help you understand why the answer for that is 9i. So if I had square root of 50, do you know, everybody write that one down. Do you know how to split that up? Because I don't know what the square root of 50 is, but I could split it up into a couple square roots. Square root of, what? Square root of 10 and square root of 5 would work, but there's something even smarter. And we'll see why in a second. Z in the back row. Yes, and why do you think I like that one better? Because 25 can just be 5, so that's 5 root 2. Have you ever seen that before? Good, because that's a concept that you need to know, and we kind of think you've seen it before. All right, so what if this had been negative 50? Well, then I'd have to just add one more thing to my little list. That square root of 25 times the square root of 2 times the square root of what? No, not I. It's a number. Negative 1. So take a wild guess what I is equal to. Not negative 1. The square root of negative 1. This whole part right here, the square root of negative 1 is what I is. I is equal to the square root of negative 1. It is a definition. Yeah, that's worthy of a star on the side of your paper, because not only is it on the ACT test, it's on our tests, and you got to know what I is. All right, we'll get in deeper into I, and the ACT test does too. They ask you like, well, what's I squared? Well, it's really not that complicated. It's square root of negative 1 times the square root of negative 1, because I squared means I times I, right? And then what is the square root of negative 1 times the square root of negative 1? Negative 1. So I is the square root of negative 1, but I squared is negative 1. And that makes problems that have I squared in them really easy to do. Because I squared, you can, whenever you see an I squared, you can just put in a negative 1 there. All right, anyway, that also should lead you to be able to answer this question really fast and easy. What's that? 8i. Just 8i. If you wanted to break it up like I just did, you'd go like this. And then you'd say, here we go. Okay? No negative sign, that's correct. I mean, this has a negative underneath the root, but when you're all done with the answer, it should not have a negative in it. It's just 8i. All right. The other one that was up there at the beginning of the hour here was this. And a lot of kids have a good guess on it, and not many kids get it right, though. Take a good guess. What do you think? X. Not right, though. It seems like it should be X. Nope. Let me explain why. What do you think? I know, it seems like it should just... So you really think it's X, right? And it is not X. All right, and it's a really common mistake. A negative X would also work, is the key to it. It's X and it's negative X. And so therefore... Okay, let me show you. No, there's no I involved in this one. I'm going to show you where it comes from. Would you agree that 4 works in this? Would you agree that negative 4 also works in this? Okay, so here's where it comes from then. When I go, okay, I'm just going to square root both sides. Square root, square root. And then I say, what's the square root of 16? And it's 4. And then I say, what should this be if I just say it's X? Do you see how I just lost one of my answers? So I have to say it's the absolute value of X, because then I could put in either 4 or negative 4, and it would make it work. So what's the answer? The answer is the square root of X is absolute value of X. I know it's a small point, but I remember one of the teachers who taught me this class when she was here years ago, she was like, you're going to see how important this is later. You may not get it right now, but the absolute value of X, it's really important that you get that this is not X. It's the absolute value of X. And it does. It comes up, in fact, in pre-calc then, which is next year's class, I'd say there's at least 4 major test questions that have this in it. And kids keep getting them wrong because they forget this. They just think they're in the middle of a problem, and you can see how easy it would be. You finally get the problem down to like this equals 162, and then you go, okay, divide by 2, and you got x squared equals 81, and you go square root x equals 9, and then you move on, and then you get it wrong. That's right. Because then that tells you that the final answer would be x would be either 9 or x would be negative 9. Two answers, not one. Yes and no. What you're asking is, can I skip showing my work? And I don't want to say yes, because teachers like you to show your work. Now, if you were in my class and you had skipped this and you'd had both answers, I'd have probably given it to you. And then I would have said, remember what that means then, that that's the absolute value of x. So it's kind of important to have that, but it's not. It's more important that you at least have both answers. All right. And it's also important to not think that it's because the square root of 89 is two things. See, some kids start thinking then, and I thought this for a while, that like the square root of 16 is 4 and negative 4, but it's not. The square root of 16 is just 4. Why? Because the square root symbol means I only want the positive answer. So it is true that negative 4 times negative 4 does give you 16, but when you use this symbol, it's called the radical. The radical symbol means principal square root, which means the positive of the two square roots. So this answer is only 4. So it only will come up when you have this situation, and you go square root, absolute value of x is got to be the positive one because I use the square root symbol, 12, and then you get your two answers, x equals 12 and x equals negative 12. All right. I know it seems like a technicality, but I'm telling you, it's going to come up. It's going to come up a lot. And it's going to come up especially a lot next year. So I want to teach it well this year. So this is not x. It's absolute value of x. All right. Moving on. Let's get into more of the stuff you're going to need to know for today. The x is the place where it touches the x-axis, and the y-intercept is the place where it touches the y-axis. But to me, there's a way better way of remembering the x and the y-intercepts, worthy of a star on the side of your notes. X-intercept is where y equals 0. Don't think of it as the spot where it touches the x-axis. Think of it as the x-intercept is where y is 0. I'll tell you why this is so powerful in a minute, but for right now, just write it down. X-intercepts where y equals 0. And then I bet you there's some smart kid that can tell me the other thing that goes with this. What do you think? You got it. I'm telling you, this, again, you're going to use it like 20 times. It's happened so often because here's what will happen. Somebody will have a problem like this, and they'll think they know what the y-intercept is because they go, oh, it's always got to be, well, there's only one number in it. It's got to be 5. But the y-intercept is not 5. The y-intercept isn't always one of the numbers that you see. The y-intercept is where x is 0. So if I go put 0 here and 0 here, I'll have 0 times 0 plus 5 is 5 equals 0. And what's the answer? 0. All right. So moral of the story is if I put in x equals 0, I'll get the y-intercept. So what's the y-intercept on this thing? 0. Yes, sir. You can think of it that way if you want to, but either way, the answer is going to be 0, isn't it? I mean, I go 0 times 0 and 0 times 5, it's still going to be 0. But if you go 0 times 5 plus 0 is 5, you're still going to get 0. All you were doing is you were distributing it out. I was doing this part first and then multiplying. Either way works. But either way, it's 0. Okay, so what I'm trying to say is this little thing I just taught you can tell you even answers to really tough questions that you don't even know the answer to right now. Y equals sine of x. What's the y-intercept? The y-intercept is where what? Well, x equals 0. And so therefore, if this is 0, do you know what sine of 0 is? Probably not, but your calculator does. You just have to type in sine of 0. Okay. So the y-intercept is 0. So for sine, the y-intercept is 0. I'll show you why. Here's what sine looks like. It starts here, and it goes like this, and it goes back and forth and back and forth. It's a big wave. Okay? Kind of like a sinus rhythm of your heart. Yep. And then this right here, that's the y-intercept, right? And that's 0. Okay, so my point is, even if you had a big, nasty equation like this, y equals 3x times x minus 4 quantity squared plus 2x. The y-intercept is where what? X equals 0. So I could figure it out by sticking in a 0 wherever I have the x. In this case, that's going to be 0. That's going to be 0. That's going to be 0. And I'd have but this 0 right here is going to cancel all of that stuff out, because it's going to be 0 times all of that makes 0 plus 0, so it's 0. Y-intercept on that one is 0. Here's another one. What's the y-intercept on that one? Seems like it should be 4, but it's not. Okay, try to figure out the y-intercept. Use your big brain. Scratch something on paper. The y-intercept would be where what? The y-intercept is where what? X equals 0. So I'm going to put in a 0 here. There's only one place to put it, so all right. So now how do I do this? I go negative 4 squared, which would be 16 times 2, which would be 32 plus 4, which would be 36. How many of you knew it was 36? All right, good. See how the y-intercept is not always just the number sitting over here? The y-intercept is where x is 0. Now, let's go back to one that you would have known before, and you would have said, oh yeah, the y-intercept is 5. Well, why is the y-intercept 5? It's because the y-intercept is where what? X equals 0, and I put a 0 here, and now it's 7 times 0 is 0. 0 plus 5 is 5. That's why it's 5. Remember, the person who knows how to do it will always have a job, but they'll be working for the person who knows why it works. It works because the y-intercept is where x is 0. And then we can do the opposite way, too. On this thing, what's the x-intercept? The x-intercept is where what? So I put a 0 here, and then how do I figure it out? I just solve it. Subtract 5 from both sides. Divide by 7. X equals negative 5/7. Here's my original. And my y-intercept was 5. My x-intercept, which is where y is 0, is negative 5/7. All right, so you can find y-intercepts and x-intercepts really fast and easy if you use that thing I just taught you. So if you wanted to find the x and the y-intercepts of this, this is messed up because it's a giant equation with 2 equal signs in it. We'll not try that one. Let's go back and do one like it, though. What's the y-intercept on that? And don't say 7. Unless you have a good reason. As soon as I say y-intercept, what should you say to yourself? Where x is 0. Put in the 0 here. And then what do? I solve it. 10y equals, and 4 times 0 is 0, plus 7, which is 7. And then y is 7/10. The y-intercept would be 7/10. All right. This one, y equals mx plus b. You came in really good at that one. This one is standard form, like 4x plus 3y equals 10. This one's really pretty good at finding y-intercepts. You know why? Y-intercept is where x is 0, right? I just put in a 0 here, and I can just solve that little equation then for y. So it's 10/3. It's quick and easy. Okay, so finding the y-intercept really isn't that bad, and it's also good for finding the x-intercept. So, like, if I wanted to find the x-intercept, I just set y equals 0. That's 0. And then I just solve that little equation. 4x equals 10, so x must be 10/4. All right. And the last one, this one, if this isn't in your notes already, you should be beaten with a wet noodle. You need that one. Y minus y sub 1 equals m times x minus x sub 1. It's huge. You can use it a ton. You can use it today. A lot. I learned it yesterday. All right. And just to make sure you understand how to use that, we'll do a couple here. Do you know that parallel lines have the same slope? You know that? Okay, good. Why isn't this moving? There we go. The same slope. Get rid of that. And the slope of perpendicular lines, do you know about them? Opposite reciprocals, yes. Okay, opposite reciprocals. For example, if it was 2, then the other slope would be -1/2. All right. That's important to know. So here, write an equation for the line given the slope and the y-intercept. Well, if they give me the slope and they give me the y-intercept, which of those forms would be best? Probably slope-intercept. Like this one, y equals 3x plus 5, because the slope's here and the y-intercept's there, right? So wouldn't it be easy to write an equation for this one? Yeah, it would. What is it? 1/2x plus 7. See how easy that was? Done. Could I have done it with the big, hairy, nasty equation? Y minus y sub 1 equals m times x minus x sub 1? Yes, it would have still worked. Because I know the slope, and I'm going to put it there. And I know a point on here, the y-intercept, and I'd put it here. The y-intercept is where x is 0, so this is 0, 7. That also helps you figuring out if it's 7, 0 or is it 0, 7, right? The y-intercept is where x is 0, so I put a 0 there. And now I got a point and I got a slope, and I can do this. I could go y minus the y of it, which is 7, equals the slope, which is 1/2, times x minus the x of it, which is 0. All right. How many of you feel comfortable using this? Just be honest. How many of you feel comfortable using this? Okay, good. So, if you feel comfortable using that, here's a point, here's a slope. Make me an equation. Starts with y minus. You don't want to be starting your worksheet now, or you will miss important stuff, and then you'll get home and be stuck. We'll do the worksheet in just a minute. Y minus, be careful now. What do you think, Dan? Yes, because minus minus means plus, equals slope. And then, yep, put that there. Now, a lot of you are going to feel compulsive about, I got to get this solved for y, otherwise that's not an equation. No, that's an equation. It's done. Do you have to put the 2 over to the other side? No. You can leave it just like that. Good enough. It's one of the things you'll learn in calc 2 classes from now, is that if you've got an answer that's right, don't mess it up by trying to change it to some other form, because you'll likely screw something up. And this, if this was a calc test and this was right, as soon as you go and try to solve it for y, you're really risking a lot, because if you do one little thing wrong, then they mark the whole problem wrong. Even though you already had it right, if you go beyond where it was right and you make a mistake in there, then they mark it wrong on the AP test. So you want to, if you've got an answer that's good enough, don't mess it up by trying to make it pretty and moving this 2 over to the other side, then multiplying this all out. You could, as long as you do it perfectly, but you don't have to. All right. So, got a Centio to do, but I don't think we really need to do it as a Centio, so I'm just going to ask you. If you had to do a line that's parallel to this, what would its slope be then? 7. And then I've got a point here, and then if you have a slope and a point, can't you use that point slope? Y minus y sub 1, x times x sub 1, yes? If you put in a -2 for the x, and you put in -3 for the y, you know what's going to happen? There's no variables left. It's just going to give you, it's just going to say that it's true. You know what I'm saying? If you want to find b, okay, you want to find b on this, b is the y-intercept, isn't it? How do you find the y-intercept? It's where what? X equals 0. Okay, so once I've got my equation for y minus y squared, you can do this any way you want to. If you really want to do this the other way, the only bad thing is you're not practicing this, which I'm telling you. I'll give you words from a calc teacher. This is more important than this. This you learned first. You learned it well. But this is more important, and you're going to use it more often as you get to high-level stuff than this. They're both good. You know this one, so you like it. But this one's very important. So I'd get used to using it. Okay, moving on. If we did this one, y equals mx plus 2, what is m? All they're asking, if they say what is m, they're really asking the slope, right? Now this one's slope isn't quite as nice, but you could solve it for y and you could figure it out, couldn't you? All right. All right, so how would I get this y alone? I go minus 3x, 2y equals negative 3x plus 12, and then you divide by 2, y equals negative 3 over 2x plus 12 divided by 2 is 6. There we go. And what is m then? Negative 3 over 2. All right. And this kind of problem. If I have given you an equation and I've given you a chart, by doing this, what did I tell you? X is what? Negative 6. So I can now go stick in a negative 6 here. And what do you think I want you to do? Solve it for y, which will involve adding 6 to both sides and then dividing by negative 3, and I figure out what y has to be. Okay? By giving you this, I'm telling you that y is what? Negative 1. And that means I put a negative 1 in right here, and then I figure out what x has to be. I'll just finish this one. So this means negative 3 times negative 1, which makes positive 2. X plus 3 equals 9. And then divide by, no, subtract 3, x equals 6. Okay? This kind of problem is pretty easy. They're just telling you to stick in x is negative 6. Or they're telling you to stick in x is 0. Or they're telling you to stick in y is negative 3. All right. Solve using substitution. All right, there's different ways to solve this. You can graph both the equations and then see where they cross on a calculator. That's a good way to do it. I think I did a little bit of that last hour with the other class, and I don't want you to be behind them. So I want you to show you how to graph it with a calculator. So if you have your graphing calculator with you, now is a good time to take it out. I have 4 up here. If you have forgotten yours today or you haven't got one yet, come up and get one of mine. Make it fast. This one's all ready to be put into your calculator. Does the calculator care if you say 5 plus x or x plus 5? No, it doesn't. You can type in either one. This one isn't ready to be put in the calculator until I solve it for y. So what should I do first? Subtract 3x and I'll have negative 2y equals negative 3x plus 12. And then what do I do to both sides? Divide by negative 2. Y equals negative 3x over negative 2 plus 12 divided by negative 2 is negative 6. So I'm going to clean that up and say 3x over 2 minus 6. Could you type that a different way? Yes, you could say y equals 3 halves in parentheses x minus 6. I don't care. Either way works. You can say 3x divided by 2, or you can say, you have to have parentheses, 3 over 2 parentheses x minus 6. They're the same thing. It's important that you get that. All right. I want you to type in this one on your calculators, y equals screen, and that one. If you haven't used these calculators much, I'll show you how to do it on mine. All right. I'm going to go to the y equals screen. Oh, the red button right there. I made it red by touching. Okay, y equals. And then, let's see if I can make this bigger. I'm going to type in 3x divided by 2 minus 6 for my first equation. So I'm going to clear out the equation that was in there. Are they supposed to be parallel? they're supposed to be crossing. Are they crossing? There we go. Okay. So just a second. 3x, 3x. The people at home can only see what's in the red there. So we'll go 3x divide by 2. And then I gotta subtract 6. And the next equation I have is this other one over here, 5 plus x. I like it to say x plus 5. It really wouldn't matter, but I like the x first. Okay, now if I hit graph, some of you guys are going to have an issue with your calculators if you're like normal classes where mine won't graph or mine is issues. Well, you can fix that by, if you want to clear your calculator and make it like factory new again, you type in the second button and then a 7, a 1, and a 2. You type second 7, 1, 2, it clears your calculator, makes it like it's brand new. So if you're having issues, your calculator's just not working, then you can clear it by going second 7, 1, 2. Oh, second plus 7, 1, 2. Sorry, there's a plus sign in there. This key right here, the plus key has the memory thing on it. Second plus 7, 1, 2. I'm sorry. Second 7, 1, 2 wouldn't have done it. Second plus 7, 1, 2. Okay, back to my screen, and I go up to this, go to my y-equals screen, I graphed them, I got them to cross, and wherever they cross, that's the answer. Oh, but they will if you go far enough out. Now, how can you, if they don't cross, because you can't see them crossing because you can only see part of the graph, that's like you're zoomed in. If I say zoom in, I bet you it'll look like what you're seeing. You see how I can't see where they're crossing? But they will if I go farther out. Then you want to zoom out. So hit the zoom button and hit out. And you got to hit it twice. Enter, enter. I'll explain that later. And I can see that they're crossing. And now, where are they crossing? You can use the trace button to see where they're crossing. Or, there's a cool way I want to show you just real quick. Above the trace, there's a thing called calculate. Using trace is kind of the caveman way of doing it. The official way to find where two lines cross is to go to second, calculate the intersection point. Right above trace, calculate intersect. And then I hit enter, enter, enter. And it tells me they intersect at 22, comma 2. Oh, 27, sorry. 22, comma 27. So that means that x is 22 and y is 27. Okay, what? Yeah. Brings you right to the intersection. 22, 27. So there's my answer, 22, comma 27. That's a lot easier than substitution. But I should show you how to do substitution anyway, because that's important to know too. So I'm going to clear this all off. And now, did somebody have a question? I thought I saw a hand out there. Question's gone now, that's okay. All right, so then, how do I do this with substitution? Substitution means I can substitute one in for another. If I have a half, I can put in 0.5. Do you agree that they're the same size? So I can substitute one for the other. Well, what is the same size as y? 5 plus x. That means wherever I see a y, I can put a 5 plus x. So I can take this y out and put in 5 plus x. And now I've got an equation that only has x's in it, and I can solve it. See what just happened there? Let me give you another one like that. 4x plus 5y equals 10, and y equals 2x. There's two equations. I could graph both of them and see where they cross. That works. Or I could do substitution, and wherever I see a y, I could put what? 2x. And I see a y right there. So I can put a 2x right there. And now I can just solve that equation. And I've got my answer. How do I solve that equation? 4x plus 10x equals 10. 14x equals 10. X equals 10/14. All right, that's called substitution. All right, that's a lot to learn in one day. Now, the reason that it's going so fast is because because we assumed that you already knew almost all of this stuff from middle school. If you didn't happen to learn this stuff in middle school, or you learned it and forgot it, that's why it feels like it's going so fast for you. So don't freak out and think, this class is so hard. It's not going to be that hard. But we're covering like that. If you had learned it originally, that would have been 6 days worth of material in the middle school. If you had learned it, if this was your first time learning it, I would have normally taken like 6 days to teach you that much. Okay? It's just we're assuming you already learned most of it. Maybe I'm assuming wrong. But the point is, we're going through a lot of material really fast right now because it's supposed to be a review. And a normal day in here is not going to be that hard. I won't have that much new stuff. New material. All right. Your homework is to just simply finish your packet. I do want to help you finish your packet, so we'll do a few together. Always feels better to me if you walk out of here with some of your homework done. So we don't have much time. Let's be specific. How much time do we have? Till 10:03. Okay, so we got about 5 minutes left, but I bet you we can get through like 4 problems. So let's look at the first problem that we hadn't done yet. Would you read it to me, please? Number what? Number 20. Go ahead. Is that it? What do they want? Oh, I like these guys. The x and y-intercept. Well, if I want the x-intercept, that's where what? So if I want the x int, I'm going to go where y is 0. 3x plus 4, 0 equals 12. If I can solve that little equation, which I bet you can, really easy, then I'll have my answer. What is it? 3x plus 0, which is 3x, equals 12. X has to equal 4. Done. So the x-intercept is x equals 4. The y-intercept is where x is 0, so I'd say 3 times 0 plus 4y equals 12. That's this original equation here with a 0 dropped in. And then I'd say 4y equals 12, y equals 3. That's the x-intercept and the y-intercept. Did they want something else? Or was that it? Cool. All right. I think you'll know how to do all 4 of those. Let's move down to number 24. Mr. B in the front row, would you read me number 24? Slope 5 and the y-intercept is what? All right. Which form should I use? Probably the one that has a slope and the y-intercept in it. So I don't need to use the big long one. I can use y equals mx plus b. And I know what m is. What is it? 5x, and then the y-intercept is? There it is. It's simple, very easy. If they give you a slope and an intercept, there's no need to do the giant equation. You could have used the giant equation if you wanted to, though, because the y-intercept is where x is 0, so it's really 0 comma negative 6. See how they really gave you a point and a slope, and you could have used point slope for it if you wanted. All right, let's do that on a different one. Give me another one that you need point slope on. 25, read me 25. One negative 2. Did I read that right? Okay, good. So y minus y sub 1 equals m times x minus x sub 1. If I were actually doing this problem, I wouldn't have written y1 and x1, and I wouldn't have written m. I would have just dropped my numbers in right off the bat. Y minus the y sub 1, there, equals m, 7, x minus x sub 1. X sub 1 is 1. Here we go. Don't have to simplify it. Everybody wants to. Everybody feels like it doesn't look right to them because they're not used to this form, but it's fine the way it is. The only other thing I'd probably do is this minus minus, change that to plus. Other than that, you do not need to solve it for y. The only time I can think of that we really would want to solve it for y is if you had to put it in the calculator, because that has to be solved for y. All right, let's move on to some of the, I guess you'll have to do the rest at home. Now there are answers online, so don't kill yourself on one problem for, 30 minutes. If you got the answers online, use them wisely. Have a good day.